Hi everyone, this is Billy. Thanks a lot for all your comments. I have incorporated all your comments and built up this model for the modular crystal radio that I'm going to make. First, we have the trap module, where we have a variable capacitor and a small ferrite coil, most likely the R401C core, and then we'll wind some least wire on it to trap or filter out the strong station that is interfering with our reception of the weak station. So the antenna will come here to the input, and then the output of the antenna will be cascaded to the antenna module. The antenna module tunes the frequency range to compensate for the length of the antenna. So it will be connected to the ground as well. And then it will be loosely coupled with the tuner module. The tuner module, like the antenna module, also has a big coil, 12 cm diameter, that will couple the signal from the antenna module. The signal from the antenna module will be selected by the resonance circuit composing of the resonance coil, this big coil here, and this variable capacitor. They determine the frequency range of the station we are going to receive. And then it will be fed to this detector. This detector module is a socket plus a diode or a MOSFET or a crystal. There's a tap selector, like the antenna module. You can tap on particular turn in the coil to compensate or adjust the impedance that will match with the detector you choose. Some detector like HSM 8520 has a very high impedance like 20K, 40K, or even 100K. Some detector like 1N34A has an impedance of around 10K to 20K. The lower impedance comes from the MOSFET like 3DQ. Their impedance is only 2K. So we can adjust the number of turns that the tap is on to connect to this detector. The output of the detector circuit will go into this headphone jack. So let's look at the back. There's the headphone jack here. Headphone jack. This tuner module can be self-sufficient. That means if you don't make the other module, just by this tuner module, it's already a self-sufficient radio. Like it has an antenna terminal, ground terminal, detector, resonance coil, and the headphone jack. But if you want to make it better, you can output the signal from the headphone jack, the audio signal, to this output module. Just connect a audio cable from the headphone jack to the input jack of this output module. There is a step down or step up transformer that will perform the impedance matching between your output of your crystal radio and your headphone of choice. I choose this KPB-02 transformer made by the Chinese factories. It has a lot of choices of different impedance, from the lower end 4 ohm up to the high end 200K. I took some time to make this very detailed and close to reality pin layout, so you can use it if you have got this KPB-02 transformer as well. I also provided a meter so you can visually look at the output signal. It starts from 25 microampere and goes all the way to 2.5 microampere by using an extension range logic, which is composed of a switch and a few resistors that will be connected in parallel with the meter. So some of the extra current will be bypassed by this resistor, and depending on what resistor you choose, you can extend the range from the initial plus or minus 25 microampere to maximum 2.5 milliampere. I have two selectors. One is for the input impedance selection. Each of these switch here connects to this either one of these tab on this transformer. So you can select the input impedance to match with that of your detector. For the output impedance, it will be used to match with your headphone. For example, if you are using a crystal or ceramic earbud, then you can go to 10K or 20K. But if you are using a magnetic loop headphone, like that of the sound powder headphone, sometimes it goes to as low as 64 or 32. You plug your headphone here into the headphone jack, and you can get the best reception. I also added a penny variable resistor. When work with some crystals or diodes, it will improve the output performance by connecting this penny variable capacitor with a capacitor. I'm going to make this radio, print out all the parts with the 3D printer, and then I will share the circuit and how I make it. Thanks a lot for watching. This is Billy from Billy C DIY.